last time I was gone Monday. I hope you guys used your time wisely and were able to get some work done. I want to start by taking some general questions from you guys about some stuff. We'll talk a little bit about the test format, and then we'll start doing some Chapter 5 things. The test is, you guys saw it, they told you it was going to be Friday instead of today, right? Okay. Which, again, no big deal to me, like, whatever, we'll just start Chapter 5 today after we get a chance to talk about our stuff. But I didn't want to come and be like, oh, test today, you didn't get a chance to ask any questions, and just have, like, you guys beating down my door all day yesterday and today during community time trying to ask me things, so we're doing this. Megan.
Okay, when it's the two vector things, when you're finding the final bearing, it's like a bearing, right, on the angle rotation?
Correct. If it asks for a bearing,
okay,
it wants a bearing.
Right.
Yep. Amanda, you were trying to ask me something here a minute ago that I asked you to hold off on.
Okay, so I have questions for the first part, just like section 4.1.
So you're referencing the review specifically, right?
Yeah.
Okay.
So sine and tangent will always be in quadrant 1 and 4, right? And then cosine will be in quadrant 1 and 2.
So sine and tangent inverse will give you an angle in quadrant 1 and 4.
Yeah.
And cosine inverse gives you an angle in quadrants 1 and 4, or 1 and 2 on your calculator, right? Like if you're just evaluating something with the inverse function, those are the locations that they're going to give you. Now, if you think about like cosine inverse of 1/2 is equal to whatever, cosine theta equal to 1/2 could be lots of places, right? It doesn't have to be just those quadrants.
Okay.
But if it's cosine inverse of 1/2, yes, it's going to be from like 1 or 2.
Okay. And then could you do section, it's like question 4, I don't know, section 4.1, it's like one of those, like A.
So like this one right here?
Mm-hmm.
Okay. So I'm going to need to use my calculator to do something like this because the decimals that we're given are clearly not unit circle values, right? Everybody's okay there? So cosine of, or cosine inverse of 0.89 is just what I'm going to type into my calculator. I'm going to make sure, though, because it's asking for a radian answer. So let me check that real quick. Turn it to degree, or turn it to radian. And then cosine inverse 0.89, because arc cosine and cosine inverse are the same thing. So there's my value. You good with that so far?
Mm-hmm.
So it's like sine of 0.47 whatevers. And then I'm just going to do sine of that answer. And I get 0.45 whatever. That's it.
Okay.
You're welcome. Jacob?
On worksheet 3, can you do number 3?
Worksheet. And by worksheet 3, you really mean, okay, worksheet 3. And which number again? Number 3. Okay. Oh, come on now, computer. Okay. It says you decide to climb onto the roof of your friend's house and scare them when you get home, or when they get home. You find a 25-foot ladder and place the base of the ladder exactly 15 feet away from the house. Okay, so there's the house. Here's our ladder. So it's 15 feet away, and the ladder's 25 feet. And we're going to assume that their house is at like a 90-degree angle with the ground. And it's asking what is the measure of the angle in degrees that is formed between the ground and the ladder. So we're looking for this angle here. Cool?
Yeah.
Okay. So the relationship between that ladder or that angle in the sides of this triangle, well, we have the adjacent side and the hypotenuse. So that's cosine is adjacent over hypotenuse. So to solve for theta, we'll do the cosine inverse of both sides. So that's what I'm going to be doing. And I think it asks for degrees, so I'll change my calculator to degree mode. And then I'm just going to do cosine inverse of 15 divided by 25. And I should be about 53.1 degrees. Okay. So you'll end up using an inverse function to get the angle out of that. Megan.
Can you do number 5 on
Sheet 7. Okay. Sparrow is planning on leaving the island of Tortuga and sailing to a secret island at a bearing of 114 degrees. Before he leaves, he checks the conditions and observes there's a 9-knot wind at a bearing of 51 degrees, an ocean current of 13 degrees at a bearing of 281. The Black Pearl has a maximum speed of 22 knots. What bearing should Jack take to get to the secret island? Okay. So we have Jack plus wind plus current should end up at the island, right? Okay. So we know the speed is 22 knots, so this is the magnitude here. For the wind, the magnitude is, 9, and the bearing is 51. We don't know the bearing that Captain Sparrow needs to take. The current has a magnitude of 13 and a bearing of 281. And we don't know the speed that we're going to be going to the island, but we know the bearing has to be 114. So far, so good with that? Okay. So I'm going to take a moment and translate that 51 degree into an angle of rotation. So that's really going to be 39 degrees. And I'm going to take that 281 bearing and translate that into an angle of rotation. So that's going to be 90 and then 79. Oops. So 169. You good with that, Megan? Okay. And now I'm going to just kind of set up the component forms here. So I'm going to have 22 cosine theta, comma 22 sine theta. And I'm going to have 9 cosine 39, 939. Actually, let's do it this way. This will be easier. So I'm going to call this length x. I'm going to call that bearing theta. So I can say x cosine 114 is going to equal 22 cosine 39 plus 13 cosine 169. And then I can say x sine is going to equal 22 sine theta plus 9 sine 39 plus 13 sine 169. Are you happy with that? Okay. This forms a system of two equations. I have two variables, two equations. I should be able to solve this system using substitution, elimination, something else, whatever. You happy there? So, seems to me, since we're looking for the bearing, I'm going to do substitution, where I'm going to solve each of these for x, and then set them equal to each other to try to get the bearing out of that. Sound good? Okay, so divide both sides by cosine 14 and sine 14, respectively, so that I can set them equal to each other. Oops. You happy there? Okay. Let's see what's going to be the most convenient way of doing this. I'm just thinking for a moment before I act. If there's any clever little shortcut I can use here other than like brute forcing this bad boy. But I think we're going to be stuck kind of brute forcing it. Let me look at something. I think I have my key written up here, save before I do something dumb and make this inconvenient. Let me look at that before I go charging off in some direction that's maybe not tremendously productive and waste a bunch of everybody's time here. You know? Like, I'm quite confident I can solve it, but I don't want to go and like make a mess out of this thing in order to do that. You know what I mean? Yeah. You get it, right? Nobody wants to see like the hardest way possible to do it. We could do that though. I already have a bit of a bad feeling that I've done something silly. Oh, I'm so silly. You ready for this to get a lot easier? Okay. Okay. That just goes there.
How do you know that it's so where
Because if it goes there, the wind and current could act on it to go faster than 22 knots, right? but its maximum speed is set as 22. So it has to be the final place it's going, it can go 22. You know what I mean? Because if it's like going 22 and then catches a big tailwind, it could be going 30 knots, which it says it can't go faster than 22.
Oh, it's back to the whole thing.
Yeah,
Okay.
yeah. So that makes life much easier, right? So then I can take this, I'm going to erase this stuff down here, because it's all, well, maybe some of it would have been salvageable, but I don't need it. So then we can say that so Jx is going to be 22, 114 is down here, so that's 24, so that is 66, so 270 plus 66 is 336, minus 9 cosine 39 minus jy is equal to 22 sine 336 minus 9 sine 169. So if we punch those into our calculator, make sure I'm in degree mode. That's about 25.9. That's about negative 17 point. So it just asks for the bearing, right, in the problem, I think. Is that correct? So if I plot 25 comma negative 17.1, it's down here. So that's going to be 90 plus my phi, which is always going to be tan inverse of the absolute value of the y component over the x component. So when I type that into my calculator, I get point. Okay with that, Megos? No problem.
Mr. Cool,
Yes.
why did you subtract everything?
Because this J is what I was looking for. So I had to get J by itself.
Okay, okay.
So I just rearranged the equation by subtracting the W and C from both sides.
Okay, okay, thank you.
Yeah, no problem. It's a good question. Certainly up in there. That's puzzling why all of a sudden we subtract instead of added. Sophia.
So for the first one, like for the, going back to like the homework quiz, when it's like in between like 7 pi over 2 and then 9 pi over 2, when do you know you have to add like cosine? You know what I'm saying? Like,
So you're talking up. Okay. So C, I see sine is negative. Sine is negative in quadrants 3 and quadrant 4. You good with Y? Sophia? Okay. And then this is 7 pi over 2 to 9 pi over 2. So let's figure out where that is. So here is pi over 2 and then 2. So this is then 5 pi, 7 pi over 2, so 2. So that's quadrants 4 and 1. Agreed? So my result is going to be in okay. So I go around, that's 2 pi. That's 4 pi. Oops. Yeah. And then that is, oh, wait a minute, sorry. So that's 2 pi. This is 3.5, 0.5, right?
Yeah.
Just turning them into decimals so it's a little bit easier to see what I'm about to do. So I'm at 2 pi. I'm at 3 pi. I'm past 3.5, right? So that must be my answer. Where my answer is, okay? You good with that?
Yeah.
Okay. So this over here is 4 pi, right? So the way I'm going to say this is my answer, my theta, is going to be 4 pi minus this piece. Is that okay?
Yeah. Yeah. What do you not like make it like the entire scale? Like, because that's what they're giving here.
You can do lots of things. There's lots of ways to approach this. I'm just showing you what I think is the simplest way.
Okay.
Is that okay? Okay. So when I'm done, if you want to, like, could I do it this way? We can certainly have those discussions. I'm happy to have that.
Okay.
Okay? I'm just going to try to finish this real quick and we can continue on. And you can go, if this works good, you can do it this way. If it doesn't work good, then we can try, I can show you a different way of thinking about it.
Okay.
Okay? I like to try to do the coterminal here before so I don't actually have to add anything at the end. Because here the calculator is going to do everything for me in this one swipe.
Okay.
And I don't have to do any adjustment at the end because I've already taken care of the rotations by using 4 pi at the end.
Okay.
You get what I'm saying?
Yeah.
Okay. So if I do that, I type into my calculator 4 pi minus tan inverse of the absolute value, sine inverse of the absolute value of 0.45. And I get I'm in degree mode, so that doesn't help. I intentionally did positive because remember and I'm done. Now, alternatively, you could have said, okay, here's my answer is what I'm going to get is this. So if I add 2 pi to this, it's still going to be too small. So I'd have to do it, and now you're playing that kind of game, but I think it's much easier to do what I did there.
Okay, so what you do is you just have to go around like a sec, like.
I'm going to draw my angle until I land inside this range.
Yeah.
And then I'm going to add or subtract my in that range.
Okay.
So I never have to add or subtract 2 pi's at the end. When I've done after I've added or subtracted my phi, I have my answer.
Okay.
Is that okay?
Yeah.
Does that seem easier?
Yeah.
That's the goal, right? Let's try to make this as simple as possible. You want to try to do another? Okay. How about E? Does that look good? Okay. So cosine is negative in quadrants 2 and 3. And then negative 3 pi to negative 2 pi. Since it's negative, we're going the other. So here's negative 1 pi. There's negative 2 pi. And here's negative 3 pi. Okay with that? So we're talking about quadrants 3 and 4. So my angle that I want is in quadrant 3. So when I draw this, that's -1 pi, -2 pi, and then I run into my angle before I've gotten to -3 pi. So my theta here, so my phi is always this part between the angle and the x-axis. So that's going to be a little bit more than 3 pi. Now it's adding this time instead of subtracting because I'm doing the reverse, right?
So how do you know which number to subtract, like the starting number? You understand?
Yep, I'm looking for the first angle on the x-axis after, before or after the phi. So you see how like this angle makes up phi?
Yeah.
So I'm using this on the x-axis. If instead I had like my phi over here, or I'm sorry, let's put it in the same spot, but we're going this direction. Here I would be, phi is here, so I'd be doing like pi plus phi.
So it would still be like -3 pi.
Well, no, look at the angle that I've drawn. I've drawn a positive angle this time instead of a negative one, because I'm going clockwise.
So you wouldn't use one that is closest to x still?
I am, but this time it's pi because I've only gone around one time and I'm going counterclockwise as opposed to clockwise.
Yeah.
If I was, say, up here as phi, so I'm phi in that location, because I haven't quite got to pi,
Yeah,
right?
so
If I've passed pi, I'm going to have to add to it. If I haven't quite got there, I'm going to have to subtract from it.
Okay, that makes sense.
But it's the opposite if the angles are negative.
Okay.
So notice there, I haven't quite got to -3 pi, but I'm adding this time because
Yeah, that makes sense.
because I'm doing negative angles. So like adding a positive to a negative is like subtracting a negative,
Yeah.
But that's it. Does that help?
That makes sense.
Okay. So again, like I try to draw the picture and rely on the picture because it's easier to me to figure out what I'm adding and subtracting from my picture than it is to like play the coterminal angle game because I don't have anything to look at. So it's like I got an answer, maybe I did it right, maybe I don't.
Yeah.
But like I don't have anything to justify like why I'm adding or subtracting this time. But if I have the picture to look at, it's like, oh, that's more than, that angle's more than what I want, so I need to be going taking some away or putting some more on. So it's hopefully easier to see that.
Yeah, that makes sense.
So you feel better on that?
Yeah.
Of course. Anybody else with questions here on this last set of topics? Bridget?
Mr. Cooley, can I ask a question about?
Yes, I'll come back to you in a second, Bridget. Is that okay?
Yeah.
Okay. Is it on this specific thing? Okay. Let's you on the computer hold, and we'll go with Bridget first, then we'll come back and get you. Oh, perfect. That's easy enough to explain. So here, all of them are positive. So tangent and cosine would be negative. Here, tangent is positive, so sine and cosine would be negative. Here, cosine is positive, so sine and cotangent, or sine and tangent would be negative. So for this one, I notice that cosine is negative. Well, that happens in these two places, right? So that's how I'm doing this half of it. Are you good with that? Okay. So that's easy to remember, right? You could also remember with the quad, like whether x or y is positive or negative, you could remember it that way, but it's the same thing as doing this, so like whatever works is fine. To do this part, I'm going to draw the picture. So because these are negative angles, I'm going to be going clockwise instead of counterclockwise. So I remember like half of a rotation is half of a pi. So that's like negative pi. So then that's to negative 2 pi. And then now that distance is to negative 3 pi. So I covered quadrants 4 and then quadrants 3. Is that okay? So I'm just kind of drawing the picture and saying, okay, starting at this end and going to the other end, what quadrants did I cover? And that's basically all I'm looking at. Okay, so once I identify where the angle is located, so I'm in quadrant 3, now I'm going to draw my angle of rotation. So again, I'm going counterclockwise. So that's negative 3 pi, but I ran into my angle, so I know I'm stopping. The phi I draw axis, so the x-axis is always one end of my phi, and the angle is always the other. Okay? So I'm going to be using the value on the x-axis here as whatever I'm going to be adding or subtracting with phi. So again, we were at 0, we went to negative pi, then we went to negative 2, almost to negative 3 pi, so that's the value that I'm going to be adding or subtracting from. Does that feel okay? Okay. So that's the way I kind of set the problem up, and to me it's all visual, so it's easier for me to know if I'm doing it right, because I'm looking at the picture going, oh yeah. So it's like, this is the spot that I need, so I just need to subtract that from this, and then I try to make it a geometry problem.
So wait, when you subtract and when you add, for instance,
Okay.
when it's not there, you add, and when it's there, you subtract, or like if it's not there.
So if I have a positive angle, so the range of angles I want, or that the answers is between are positive, I'm going this way. If I haven't crossed the x-axis, if the axis I crossed was not most recently the x-axis, here I'm going to be subtracting. If I was, say, here, and the axis I most recently crossed was the x-axis, there I'm going to add. If I have a negative angle, everything is just reversed. Oh, no, I lied. It's still the same. Sorry. Yeah. That's what you needed, Sophia?
Yeah.
Does that help? And again, what I'm writing right now is in the content library, right? So you don't have to like panic if you think you screwed something up, or you're like, oh boy, I wish I would have written that down. You did something in class. You can always go back and look at it. But this is in particular was this area that seemed like everybody had the hardest time on the homework quiz with. If you noticed, I passed those back and graded them or whatever. But this kind of a question was the one that many of us had a hard time with. So I don't mind spending some time here and trying to clarify this and making it maybe a little bit easier. Great. Okay. So you can't be in quadrant 4 and have just passed the x-axis unless you're talking about a negative angle.
Like, you went all the way around.
So like You're talking about
Yeah.
that? So we haven't yet crossed the x-axis, right?
Yeah. Well, you did once.
Well, it's not the most recent axis I've crossed,
Oh, okay.
right? I haven't, is that okay?
Yeah, that's
Okay. So here, if this is phi, I'm going to do 2 pi minus phi.
okay.
Because again, this is the phi angle, so I need this location. And I haven't quite got there yet, so I need to subtract. Is that, Bridget, you feel okay there? Okay. My at-home friends, Leah or Jesse, it sounded like one of you two were getting ready to ask me a question. I asked you to hold on for a second. I'm now ready to address whatever that question was, if you're still interested.
You answered my question. Thank you, though.
I'm amazing. I didn't even know what it was, and I did it. You're welcome. I'm happy to help. Okay. Anybody else? Last call on this stuff. Okay, cool. So test format stuff. Look at that. Okay. So you have the first two questions. I'm just going to ask you to use your calculator to find the inverse or the value for an inverse. So that's like what Amanda was asking. You have to make sure you know what quadrant your calculator's outputting, but your calculator is going to give you the number. You don't have to do anything after that. You just have to get the number out of the calculator. But it's okay to get like a wacky negative decimal or something. That's okay. That just means it's giving you a quadrant 4 answer, which can happen, right? No big deal. 2 questions where I ask you to find the exact value for the angle. In that case, you're going to be using the unit circle, but you're still going to report the answer as either a quadrant 1 and 4 or a quadrant 1 and 2 answer, depending on which inverse it is. To give the exact value for the angle. You'll have one like, or I'm sorry, 2 like, who was the first person that asked about the thing? Like this one from the review that we did? I can't remember who asked about this. Was Amanda, you asked about it? Okay. Yeah, you'll have 2 like that, except I'm going to give you things that you can find exact values for, so you'd use the unit circle to do it rather than your calculator, but same type of question.
Wait, Mr. Kulik, what did you say it was?
Like this question, like 2 of these.
Oh, okay. Thank you.
Yeah, like the ones here in this section. You're welcome.
So would it be more like questions like one that
Sure. Or even if this number was like a half, or like square root of 2 over 2 or something, like unit circle-y.
so you wouldn't use your calculator?
if you're asking for an exact answer, have to be using the unit circle. Your calculator will not give you the exact answer because all of them are in terms of some irrational number, right? The angles are in terms of pi's. Calculator's not going to give you an answer in terms of pi. Most of the sine, cosine, or tangents have square roots in them, won't give you the answer with a square root in it. You'll have to use the unit circle to get it if it's asking for an exact answer. If it just asks you to round, then calculator it up, dog. You'll have one question where we have to find the algebraic expression like we did on worksheet 3, I think. Is it worksheet 3? No. It's worksheet 4. Sorry. Yep, just like in worksheet 4, these ones. Where your answer had like expressions of x's in it. You have one question where I ask you to find or to use reference triangles to find the angle inside the given range. So like those questions that Sophia was just asking about that we spent a bunch of time talking about and Bridget followed up on. I mean, I just made up words. So it's like, where is it? It's problems like these ones from the review where I ask you to find like sine of something on this inside of this interval. Is that okay? Okay. You'll have like a basic story problem where you just end up having to draw a triangle or whatever. You'll have one of those. You'll have one more complicated story problem where you have a system that you'll end up having to solve. And then you'll have one vector story problem.
For the vector one, I don't know if you can pause this, but is it going to be like the one that I asked about where we just be like a regular?
It'll be like, I would say, a easy version of a vector problem.
Okay, so then you just give us a very
Yes. There won't be much in the way of story interpreting. So it'll be pretty obvious what to do with it. Okay? Does that feel all right?
Chapter 5, can you do more in the gas questions?
I mean, we need to move on. We just did like an hour of questions, 40 minutes of questions. It's okay?
Yes.
I mean, like, I want to help, but like, we got to do stuff too. Like, where you're putting us a day behind if we spend all day today doing questions on that. Yeah, of course, Taylor. I mean, we'll do it. We can do like one more. It's okay. I mean, we can do one more. Does that help?
No, it's okay.
All right. Okay. So our new section, our new chapter. It's exciting. This is my favorite topic in trigonometry because it's like puzzles. You guys like puzzles? So when we say identity, what we're talking about is an equality statement that's valid for all values of a given variable. So like a silly example of something you could consider an identity would be something like this, right? That's always true regardless of the value for x. Everybody's okay with that notion of what we mean by an identity? Okay. In trigonometry, we have a bunch of these that we're going to use. Some of them you're already familiar with. For example, the reciprocal identities. So we know that cosecant theta is the reciprocal of sine. Secant theta is the reciprocal of cosine. Theta is the reciprocal of tangent. Everybody's okay with that? You remember those from previously? And if those are true, I should be able to do the reciprocal of both sides to say like sine theta then is 1 over cosecant. Or cosine theta is 1. Or tangent theta is 1 over cotangent. Woo. So we have these 6 reciprocal identities that we've already pretty familiar with. These quotient identities. So remember, tangent on the unit circle was y over x, right? Everybody remember that? Remember, on the unit circle, y is sine and x is cosine. So we could also say that tangent is equal to sine over cosine. And similarly, cotangent. So that has to equal cosine over sine. So there's 8 identities now. The next one is called the Pythagorean identities. These are new. So our first one is sine is equal to 1. Well, that seems bizarre, Mr. Kulik. Why the heck would that be true? Let's prove it. Sine is equal to opposite over hypotenuse, right? and cosine is adjacent over hypotenuse. So that's going to give me opposite squared plus adjacent squared over hypotenuse squared. But what's opposite squared plus adjacent squared equal? Remember, this is all relative to a right triangle. So what is opposite squared plus adjacent squared equal? Hypotenuse squared. Why is that true? That's just a Pythagorean theorem, right? And hypotenuse squared over hypotenuse squared then is just 1. So there's our proof. That wasn't so bad. So that's our first Pythagorean identity. Our next one is 1 plus cotangent squared theta is equal to cosecant. Well, again, let's prove this. I'm going to be a little bit more clever here. This is equal to 1. I can divide both sides by still hold, right? Everybody's okay with that idea? We can do that, divide both sides of an equation by a value. Well, sine squared over sine squared is just 1. Cosine squared over sine squared, well, I know cosine over sine is one of our quotient identities. That's cotangent. So cosine squared over sine squared must be cotangent squared. Similarly, I know that 1 over sine is one of our reciprocal identities. That's cosecant. So 1 over sine squared must be cosecant squared. Is done. Ooh. And our last Pythagorean identity is tangent squared theta plus 1 is equal to secant squared theta. So again, let's prove that. So again, I'm going to start with, but this time instead of dividing both sides by sine, let's divide both sides by cosine squared, excuse me. Yes, sir. Cosine squared? You're welcome. Now, sine over cosine identities, that was tangent. So sine squared over cosine squared must just be tangent squared. Cosine squared over cosine squared is just 1. 1 over cosine was one of our reciprocal identities. That was secant. So 1 over cosine squared must be secant squared. And that's what we're looking for. So that proof is done. Our next group are the co-function identities. There's 6 of these. I'm going to present these without proof, but I'm going to explain to you a little bit of the relationship. So, you know how some of these trig functions have that prefix co in front of them? Like cosine or cosecant or cotangent. The co stands for complementary. Because what is pi over 2 the same as in degrees? 90, right? So 90 minus theta is simply the complement of angle theta. So if I had cosine of 40, that should give me the same value as sine of its complement, 50. That's it. That's the idea. And we already know this to be true for 45, right? Sine of 45 is equal to cosine of 45. We've seen it works for 30 and 60, like sine of 60 is cosine of 30. Right, on the unit circle, you've noticed that those are the same coordinates. They're just flip-flopped. The next ones are the odd-even identities. So sine is an odd function. So the negative on the inside can be moved to the outside. Cosine is an even function, so the side just gets absorbed and goes away. Tangent is an odd function, so the negative on the inside can be moved aside. And if sine is odd, so is cosecant. It's reciprocal. If if cosine is even, so is secant. If tangent is odd, so is cotangent. Bless you. You're welcome. So we have 6 more of those. I just kerslammered you with identities here today. That's it for the identities for this chapter, I believe. From here on, we're going to be working with these identities to kind of, solve some kinds of problems and things. So we'll start doing a couple of examples here. You'll notice in the content library, I've already put in the basic trig identity sheet that contains all of these identities that we've gone through today in one location, which is nice. Megan? Not for this test, but eventually they'll become common knowledge because you'll use them so much you'll have to have them memorized. But not for this first one. Does that sound fair? I believe is how this is set up. I have to go back and look at my stuff, but I think that's what it's going to be like. So the answer is eventually, yes, right away? No. And a lot of these you're going to see, some of them are much more valuable than others that you'll see you'll use all the time. And some you'll be like, I've never even used that one, which is fine. Okay. Example yet, right? We've just fired through a bunch of identities. We don't even know what we're going to do with them yet. So let's give some examples. Okay. So let's say we want to find the value of sine if tangent 3 and cosine is negative. So we can do this using identities now. So first thing I'm going to note that involves tangent and just one other trig function. The identity that I'm going to use, or that you would need to use, because it's the only one that involves tangent and only one other trig function, is this Pythagorean identity, 1 plus tangent squared is equal to secant squared. That's the only function that involves, or identity that involves tangent and just one other thing. Everything else involves tangent and two other things. Well, that doesn't really count. That's okay. That's a fair point, though. Ben, that the reciprocal ones are going to be kind of useless for something like this, because all it's going to tell you is that, okay, well, cotangent is 1/3. Cool. Doesn't help. Okay. So I know then that I can say that then, right? Which tells me this. Cool. And if I square root both sides, I get then that secant is plus or minus the square root of 10. And since cosine is negative, I know that secant is also negative. Everybody's okay with that? And now I can say that using the reciprocal identity, cosine is going to be the reciprocal of secant. Yes. We good there? Now I'm going to look for an identity that involves cosine and sine, or since I know tangent, I could look for cosine and tangent and sine. Or I could look for, since I know secant, I could look for one that involves sine and secant or tangent. Anyways, the one I'm going to use is that tangent theta is equal to sine over cosine, because it's easier to rearrange. So I can just multiply cosine to both sides. So I can say